Hi, hello everybody. So this is section 18 dealing with rational exponents. This section, we're going to cover that sometimes it's necessary when we have a radical expression, meaning an expression that has or involves the radical symbol, uh, to be converted to an expression that has rational exponents, meaning an expression as you see here on the left side which has a base to a power, and that power is going to be a fraction. But since we cannot apply the definitions of exponents to a rational exponent, we need to convert that to a radical expression, the one that you see here on the right. Now, so this is the special case when we have the numerator of the fraction as 1. So I'm going to give you a better definition of this, and that's the one that we're going to use in class and that I want you to remember for the exams. So take a look here. So as you see here, this is the generical case of conversion between a radical expression, the one you see here on the left, to an exponential expression, the one you see here on the right. So imagine that we have a radical symbol as you see here. We have, let's say, a variable x. The index of the radical expression is n, and the exponent to x is m. Now, if we have this scenario, then the conversion is variable x. The exponent to x becomes the numerator, and the index to the radical is the denominator. So for example, let me just do something here on the side so that you can see. So if I have something like this, the conversion would be x 4/3. Okay. And in the most common case, if we have a basic square root, right? Let's say 3. Now, you remember when you have a square root, the default of the index here doesn't need to be visible, it's 2. So the conversion here would be 3, and the invisible index is 2. Okay, so this is the conversion I want you to use. It's very, very important, and it covers the case where the value m is 1. So sometimes it's necessary for us to convert. So for example, like in problem 18.4, we write using radical notation, simplify if possible. Sometimes it's going to be possible to simplify, sometimes it will not be. So notice that in this case, I am given the exponential format, the one that's on the right, and I need to go to a radical format, the one that's on the left. So how do we do this? So you write the radical symbol, 64 is the base, the numerator 1 is in here, and the denominator 2 is the index of the radical. So 64 raised to the 1/2 is nothing more than the square root of 64, which we know we can simplify to 8. Okay, so this is basically what it is. So 18.5, same thing. Convert the expression to radical notation. So you write the radical, you write minus 64. The 1 is the exponent, and the 3 is the index to the radical. And we know this is the cubic root of minus 64, which is minus 4. In case you don't remember, how do we find this? It's minus 4 times minus 4 times minus 4 is minus 64. Okay, so this is very simple, provided that you remember the conversion factor I gave you up there. All right, so let's do a couple more. 18.6, I guess I can do 18.6, same as before. Write the radical, write the base. The numerator exponent goes here, and the denominator goes there. So this is the fifth root of 32, and you can check this is 2. Why is it 2? Because 2 times 2 times 2 times 2 times 2 is 32. Okay. And let's do one more. And the other ones you can do for practice. Oops. Just make sure that I don't mess it up. Okay, scroll up a little bit here. Okay, so let's do 18.9. So rewrite using rational exponents. So this is the radical expression. To rewrite using radical exponents, this whole thing acts like the base. So we write it 7, x to the fourth, y to the third, z to the fifth, parentheses. There's like an invisible 1 right here. And this number goes there. Okay, so you could leave it this way, or sometimes you can simplify a little bit. So now we apply properties of exponents, and we're going to review them shortly. But it would be 7 to the 1/6 times x to the 4 times 1/6, which is 4/6, times y to the 3 times 1/6, times z to the 5 times 1/6. Okay. Now, sometimes you can simplify the fraction. I can simplify this fraction. I can simplify this fraction. The rest, I can leave it the way it is. So 7 to the 1/6. I can simplify the 4/6 by 2. I will get 2/3. Same thing here with the 3/6. I get 1/2. And z 5/6. Okay, so we've converted the radical expression into an exponential or rational expression. Now, 18.10 is similar to 18.9, so I'm not doing that. You can do that for practice. Let's just take a look at 18.11. So in this case, I have a fraction here. So we can break it as the following. Okay, x squared and y. And now we can work with the numerator and we can work with the denominator separate. We apply the conversion. So remember what the conversion is, right? So here's the generic form of the conversion. So I will have on the numerator x 2/3. And down here, there's an invisible 1. Y 1/3. And that's all I can do because the variable x and y are different. I stop right here. So radical expression, rational or exponential expression. Okay. And 18.9 is very similar to the one that we had right up here. In fact, I think it's the same one. I copied it twice. So I'm not doing that. We already did this one, I think. Yep. So I copied it again, or it was in the book. Yes, I copied it again. So I won't do these. I already did those. Now, let's review quickly. Just shrink this just a tiny bit. These are the properties of exponents as we've seen them before. And I'm just placing them here so that we can take a look briefly and remind ourselves exactly what they are. So we have the product rule when we are multiplying variables with different exponents. And as you can see here on the example, If I have x to the fifth times x to the third, we add the exponents. So product rule. The quotient rule is when I am dividing them, like x to the ninth over x to the fifth under the example. And then we do 9 minus 5 for the exponent and we get 4. Now remember, it's always the numerator's exponent minus the denominator's exponent. Power rule, when we have an exponent of another exponent, here's the example, x to the third raised to the fourth power. So in that case, we multiply the exponents to get x to the 12th. Now don't confuse this with the product rule, case number 1. When we have two variables being raised to the exponent, each variable is raised to that exponent. Okay, so for example, I probably can show you a better example than this. So if you have 4x to the third square, you're going to raise 4 to the second power and then x to the third to the second power. So you will get 16 x to the sixth. Remember that when we have a negative exponent, so this is the negative exponent property, we can never leave the final answer with a negative exponent. So wherever the negative exponent is, it goes to the other side of the fraction with a positive. So in the first case, the negative exponent is in the numerator, so it goes to the denominator as positive. So x to the minus 3 is equal to 1 over x cubed, and that's the answer that we would want. If the negative exponent, the last case, is in the denominator, it goes up to the numerator as positive. So if I had 1 over x to the minus 5, the x to the minus 5 goes to the numerator and it becomes x to the positive 5. Okay, so these are the properties that we kind of have to remember to simplify these rational exponent expressions. So let's take a look. I think I have about 5 problems or so that we can do now. And these are exactly the same. You would do them exactly the same as if the exponents were regular whole numbers. And I'm going to give you an example here on the side. So we'll do 18, 19 first, but here's something very similar. So let's say if I had x squared, 7 to the second power, 7 to the first power, okay? Now remember, don't multiply the sevens. So the answer would be 7 to the third power. And then you would evaluate what 7 times 7 times 7 is. I'm not going to do it now, but that's what we do. So we just add the exponents. There's absolutely no difference when the exponents are rational. So the bases are the same. You keep the base, and then you're going to do 2/3 plus 1/3. Now, obviously, that is 3/3, which is 1. So the answer to this is just 7. All right. Second case. So this is very similar to something that we've done before. We'll handle the number. So 28 divided by minus 7 is minus 4. And then we'll handle the rational exponents. And in this case, we have to apply the quotient rule. So this will be a 7 to the 7 over 8 minus 1 over 8. So minus 4, a 6 over 8, and simplify the fraction. So this will be, we can simplify by 2, 3/4. Okay, and this is my final answer. 1821. So this is the property as if I had something like this, for example, x squared to the third power, you multiply these two values. So this will be x to the sixth. You do exactly the same over here. So this is x 2/3 times 3/4. All right, so the 3's cancel, and I have x 2/4, and we can simplify the fraction by 2, and we get x to the 1/2. So all of these expressions where we have to simplify, right? Simplify, simplify, simplify. We are going to apply the exact same properties of exponents that we used on whole numbers as exponents, all right? So there's absolutely no difference when the exponents are rational. All right, so let's take a look at the last two problems right here. These are probably more important, and we're going to see them in the next section. So this, the question is asking us, rewrite with rational exponents and simplify. So sometimes, like I said before, it will be possible to simplify. Sometimes it won't. I guess in these two cases, it will be possible. So remember what we did before. When we have something like this, it is more convenient to break the problem into parts. So I have cubic of 64 and then cubic of x9. All right, this is easy to do. We already know that this is a cubic of 64 is 4. And this one, we can rewrite this in exponential form, right? So this, remember the conversion. I'm going to write it here again so you don't forget. So this will be x to the 9th over 3. And then we simplify this, the 9 over 3. So this will be 4x 9 over, divided by 3 is 3. So this is final answer for x cubed. Okay. Second case, we're going to do the exact same thing. We're going to break this problem in two because it has two parts. So here's the radical 8, x4 times radical 8, y squared. In both of these cases now, we convert each to their respective exponential format. So using this conversion ratio right here. So x to the 4 over 8 times y 2 over 8. And then we simplify each of the fractions. So 4 over 8 is 1/2 times, and 2 over 8 is 1/4. Now, this is the final answer. Don't confuse this. Now, we cannot combine the two because x and y are different variables. Okay, so this is the final answer for this problem. And this is the final answer for that problem. So this is section 18 dealing with these conversion techniques from radical to exponential.